Chapter 8 Water. Water is one of the most important resources and is a universal solvent. Students will be enabled to know and understand that it is important for all living beings, animals, human beings, plants and trees, comes from different sources and has many uses. There are different sources of water such as sea, well, river, lake, pond and rain. We use it daily for washing, bathing, drinking and in industries. Water helps in controlling the temperature of the atmosphere. Learning outcomes. After studying this chapter, students will be able to describe that water dissolves many substances and it is a universal solvent. Identify a solution, suspension and colloid on the basis of properties. State the differences between saturated, unsaturated and supersaturated solutions. Describe water of crystallization. Write equations of metals with cold water and steam. Describe hard and soft water. Discuss the different methods of softening of water. Important terms and their definitions. Water cycle. The water on the earth is always on the move. It circulates in a constant cycle called water cycle. Soft water. The water which lathers readily with soap is called soft water. Hard water. The water which does not lather with soap is called hard water. Potable water. Water which is fit for consumption by humans and other animals. Solvent. A substance that dissolves other substances. Chlorination, it is a method used for purifying water. Homogeneous mixture, a homogeneous mixture has a uniform composition and appearance throughout its mass. Heterogeneous mixture, a heterogeneous mixture does not have uniform composition throughout its mass. Introduction. We use water for various purposes like drinking, bathing, cleaning, cooking, washing, etc. Water also plays an important role inside our bodies. We need water for digesting food, transportation of digested food to various body parts, and also for dissolving waste materials and removing them from our body. Water is also required by plants and animals. Life is not possible without water. The present chapter is all about water, its importance and utility. Dissolution of salts in water. When we mix two substances and the result is a homogeneous mixture, we are dealing with a solution. In the case of common salt mixed with water, Na and Cl atoms initially bonded together in the form of a crystal are dissolved by molecules of water. Water is a solvent. The reasons are electrostatic in nature. The cohesion of atoms and molecules derive from electrostatic links between particles that are charged or polar. Sodium chloride NaCl is in fact the joining of a Na plus ion and a Cl minus ion which mutually attract one another via electrostatic attraction. Water molecules are electrically neutral, but their geometry causes them to be polarized, that is, the positive and negative charges are positioned in such a way as to be positive one another. This property makes the Na positive and Cl negative ions break apart under the stronger attractions provided by the water molecules. Here it is noticeable that the orientation of the water molecules is not the same when it is attracting an Na plus or positive ions as it is when attracting a Cl minus or negative ion. This process continues until the salt is totally dissolved. Solutions. When two or more chemically non-reactive substances are just mixed, they form a mixture. The mixture may be homogeneous or heterogeneous. A solution is a homogeneous mixture of two or more chemically non-reactive substances. For example, when sugar is added to water and shaken, it apparently disappears, but it is very much there because the mixture tastes sweet. This homogeneous mixture is called solution of sugar in water. In this solution, there is homogeneity at particle level as the solution tastes the same throughout. This shows that the particles of sugar are evenly distributed in the solution. Solute and solvent. The substances that make a solution are called its components. If the solution is made by mixing only two substances, it is called a binary solution. In a binary solution, the component present in smaller proportion is called solute and the other one present in larger proportion is called solvent. Hence, in a sugar solution, sugar is solute and water is solvent. Examples: in a solution of salt in water, salt, sodium chloride, is solute and water is solvent. Soda water has carbon dioxide gas as solute and water liquid as solvent. Types of solutions. In a binary solution, solute and solvent can be either solid, liquid or gas. Hence, it is possible to have following types of solutions. Out of the various types of solutions, the most significant are those which are present in liquid phase. Aqueous solution. Solution of a substance in water is called an aqueous solution. Solvents other than water are often referred to as non-aqueous solvents, referred to as non-aqueous solvents. The common non-aqueous solvents are ether, alcohol, benzene, carbon disulfide, carbon tetrachloride, acetone, liquid ammonia, etc. Non-aqueous solution. Solution of a substance prepared by dissolving it in a non-aqueous solvent is called a non-aqueous solution. Characteristics of a solution. A solution or a true solution shows the following characteristics. A solution is a homogeneous mixture of solute and solvent. Solute particles in solution are generally of molecular size or smaller. Solute particles do not settle out from the solvent on standing. Solute particles cannot be separated from the solvent by filtration. A true solution is clear and transparent but may be colored. A true solution does not scatter light, therefore path or light is not visible when light passes through the solution. Saturated and unsaturated solutions. There are different types of solutions, but the common among them are the solutions obtained by dissolving a solid solute in a liquid solvent. A saturated solution is that solution in which the maximum amount of solute has been dissolved at a particular temperature. Thus, a saturated solution contains the maximum amount of the solute that could be dissolved in a given amount of the solvent at a specific temperature. In case the solution is less than the maximum amount that can be dissolved, the solution is called an unsaturated solution. The saturated solutions of different substances have different amounts of solute present in a particular amount of solvent, that is, their solubilities are different. Supersaturated solution. Under certain conditions, a solution may be made to contain more solute than a saturated solution at the same temperature and pressure. Such a solution is called supersaturated solution. If the temperature of the sugar solution is raised and then more sugar is added to the solution and stirred, the sugar dissolves. This shows that a saturated solution becomes unsaturated on heating. On the other hand, if a saturated solution available at a particular temperature is cooled to a lower temperature, crystallization would take place. A saturated solution generally becomes unsaturated on heating. Solubility. The maximum amount of a solute that can be dissolved in a specific amount of the solvent at a given temperature is called the solubility of that substance or solute. Solubility is the number of grams of a substance or solute that can be dissolved in 100 grams of water or solvent at the specified temperature to make a saturated solution. For example, a maximum of 36 grams of sodium chloride can be dissolved in 100 grams of water at 20 degrees centigrade. Hence, the solubility of sodium chloride in water is 36 grams at 20 degrees centigrade. Remember that solubility of a substance refers to a saturated solution of that substance at the specified temperature. Solubility of some solid substances in water at 293 K or 20 degrees centigrade is given below. Solubility of some solid substances in water, solubility at 295 K, sodium chloride 36 gram, potassium chloride 34 gram, potassium nitrate 32 gram, ammonium chloride 37 gram, copper sulfate 21 gram, sugar 204 gram. The solubility is influenced by the following factors: nature of solute. Different substances have different solubilities at a given temperature. Nature of solvent. A given solute will have different solubilities in different solvents at the same temperature. Temperature. Normally, solubility of a solid in a liquid solvent or water increase with an increase in temperature. but the solubility of certain substances like some compounds of calcium decreases with an increase in temperature. The solubility of a gas in a liquid decreases with rise in temperature. Pressure. The solubility of a solid solute in a liquid solvent is not affected by a change in pressure. The solubility of a gas in a liquid is much affected by pressure. The solubility of a gas in a liquid increases with increase in pressure and decreases with decrease in pressure. Concentration of solution. The proportion of solute to solvent in a given solution is expressed by the concentration of the solution, or we can say that the relative amount of solute and solvent present in a solution is known as the concentration of solution. There are a number of ways to express the relative amounts of solute and solvent in a solution. Mass percentage, percentage by mass. Mass percentage is defined as the number of parts by mass or weight of the solute dissolved in 100 parts by mass or weight of the solution. For example, a 10% solution by mass of sugar in water means that 100 gram of this solution contains 10 gram of sugar. Formula: mass percentage is mass of solute by mass of solution into 100, or mass percentage is mass of solute by mass of solute plus mass of solvent into 100. Percentage composition by mass or weight of a solution is generally represented as percentage W by W. Volume percentage or percentage by volume. Volume percentage is defined as the number of parts by volume of the solute dissolved in 100 parts by volume of the solution. For example, 5% by volume of a solution of ethanol in water means that 5 cm cube or 5 ml of ethanol is present in 100 cm cube or 100 ml of the solution. Formula: volume percentage is volume of solute by volume of solution into 100, or volume percentage is volume of solute by volume of solute plus volume of solvent into 100. Percentage composition by volume of a solution is generally represented as percentage V by V. Mass by volume percentage. Mass by volume percentage is defined as the amount of solute in parts by mass present in 100 parts by volume of solution. The volume of the solution is expressed in liters dm cube and the amount of solute is expressed in grams. Formula: mass by volume percentage is mass of solute in gram by mass of solution in liter into 100. Strength of solution. Strength of a solution is defined as the amount of solute in grams present in 1 liter of solution. It is expressed as strength is equal to mass of solute gram mass of solution liter. Dilute and concentrated solutions. A solution having low amount of solute as compared to that of the solvent is called a dilute solution. On the other hand, a solution having a large amount of solute in the solution is called a concentrated solution. Suspensions. A suspension is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving in it. For example, when sand is stirred vigorously with water, the sand particles get distributed evenly in water and we get a suspension. After some time, the particles of the mixture, that is sand particles, settle down under the influence of gravity. Properties of a suspension. Following are some of the properties of a suspension. The particles of a suspension scatter light passing through them and make the path of light visible. A suspension is a heterogeneous mixture. The size of suspended particles is greater than 100 nm. The suspended particles can be seen with the naked eye or under a simple microscope. When left undisturbed for some time, the suspended particles settle on the bottom of the container under the influence of gravity. Suspended particles can be separated from the fluid medium by decantation or filtration. Colloids. Colloid is a state of subdivision of the substance. The colloidal state is intermediate between a true solution and a suspension. In 1861, Thomas Graham observed that substances like gum, starch, glue, etc. in dissolved state either do not diffuse or pass very slowly through parchment paper or animal membrane. He called such substances colloids. A colloid or a colloidal system is a heterogeneous mixture in which one substance is dispersed as very fine particles having size in the range of 1 to 100 nm in a continuous medium of another substance. The discontinuous phase of fine particles is called dispersed phase. and the continuous phase is called dispersion medium. Fog is a colloid in which very small droplets of water are dispersed in air. Milk, butter, whipped cream, bread, gum paste, jam, jelly, smoke, etc. are all colloidal in nature. Types of colloids. Dispersed phase and dispersion medium can be solid, liquid or gas. Therefore, 8 types of colloids are possible depending on the physical state of the dispersed phase and dispersion medium. A gas mixed with another gas does not give a colloidal system because gases mix with each other to give a homogeneous.
Different types of colloids.
Colloidal solutions. Colloidal solutions or sols are of 2 types, licophilic sols and lycophobic sols. Licophilic sols, the word licophilic means solvent loving. Substances like gum, starch, gelatin, etc. when mixed with a suitable solvent like warm water readily form a colloidal solution. The colloidal solution thus obtained is called licophilic or hydrophilic sol if water is dispersion medium. Lycophobic solutions, sols. The word lycophobic means solvent hating metals, their oxides and sulfides, etc. when simply mixed with the dispersion medium, say water, do not form a colloidal solution. Special methods are to be employed to prepare colloidal solutions of these substances. The sols of these substances thus obtained are called lycophobic or hydrophobic sols if water is dispersed medium. Properties of colloidal solution, colloids. Some important characteristic properties of colloidal solutions or colloids are as follows. Colloidal solutions or sols apparently appear to be homogeneous like a true solution, but they are actually heterogeneous in character. The size of colloidal particles ranges from 1 nm to 10 nm. Colloidal solutions pass as much through ordinary filters, therefore colloidal particles cannot be separated from the dispersion medium by simple filtration, but by using ultrafilters the dispersed phase and dispersion medium can be separated. Tyndall effect. When a strong beam of light is passed through a true solution, the path of light is not visible. However, when the same beam of light is passed through a colloidal solution, the path of the light becomes visible with a bluish light as shown in the figure below. This phenomena is called Tyndall effect. Tyndall effect is due to scattering of light by colloidal particles. It can be observed when fine beam of sunlight enters into a room through a small hole. The dust particles dispersed in air scatter the light and the path of light becomes visible. Similarly, when sunlight passes through a canopy of forest, colloidally dispersed small droplets of water in air, that is mist, scatter the light. Scattering of light by smoke or dust particles produces a rich red sunset. Differences among true solution, colloidal solution, colloid and suspension. Water of crystallization. A crystalline salt molecule that is loosely attached to a certain number of water molecules is called hydrated salt. These water molecules are incorporated into the crystal structure of the salt. These water molecules are known as water of crystallization. Every hydrated salt has a definite number of molecules of water of crystallization in its one formula unit. For example, copper sulfate crystals contain 5 molecules of water of crystallization in one formula unit, that is CuSO4 5H2O. Copper sulfate pentahydride. Some other examples are given in the following table. Molecules of water of crystallization are integral part of the crystal structure of salt. Since water of crystallization is not free, it does not wet the salt. Action of heat on hydrated salt. When a hydrated salt is heated, it loses its water molecule of crystallization. Due to loss of water of crystallization, the salt may lose its crystal shape and become powdery substance and lose its color as well. The salt which has lost its water of crystallization completely is called anhydrous salt. For example, copper sulfate crystals CuSO4 5H2O are blue in color. When these crystals are heated strongly, they lose all the water of crystallization and form anhydrous copper sulfate, which is white in color. Remove the boiling tube away from the flame and allow it to cool. Now add few drops of water. You will observe that anhydrous copper sulfate white turns blue. This is due to formation of hydrated copper sulfate again. CuSO4S anhydrous copper sulfate white plus 5H2OL water is CuSO4 5H2O hydrated copper sulfate blue. This property of anhydrous copper sulfate is used to detect the presence of moisture in a liquid. Hygroscopy. Those substances which absorb moisture from atmosphere at ordinary temperature are called hygroscopic substances, and the property is known as hygroscopy. For example, concentrated H2SO4, anhydrous calcium chloride, etc. are hygroscopic substances. Deliquents. The substances which absorb moisture from atmosphere at ordinary temperature and ultimately dissolve in the absorbed water to form a solution are called deliquent substances, and the deliquescent substances, and the phenomena is called deliquescence. For example, NaOH, KOH, etc. are deliquescent substances. Efflorescence. Some hydrated salts when exposed to atmosphere at ordinary temperature lose their water of crystallization either partially or completely. Such salts are called efflorescent salts, and phenomena is called efflorescence. For example, washing soda, Epsom salt, etc. are efflorescent salts. Reactivity of metals with cold water, hot water and steam. Reaction of metals with cold water. All the alkali metals react vigorously with cold water. In each reaction, hydrogen gas is given off and the metal hydroxide is produced. The speed and violence of the reaction increases as you go down the group. This shows that the reactivity of the alkali metals increases as you go down group 1. Reaction of lithium with cold water. When lithium is added to water, lithium floats. It fizzes steadily and becomes smaller until it eventually disappears. Lithium plus water is lithium hydroxide plus hydrogen. 2LiS plus 2H2OL is 2LiOH AQ plus H2G. Reaction of potassium with cold water. When potassium is added to water, the metal melts and floats. It moves around very quickly on the surface of the water. The hydrogen ignites instantly. The metal is also set on fire with sparks and a lilac flame. There is sometimes a small explosion at the end of the reaction. Potassium plus water is potassium hydroxide plus hydrogen. 2Ks plus 2H2OL is 2KOH AQ plus H2G. Reaction of sodium with cold water. When sodium is added to water, the metal melts to form a ball that moves around on the surface. It fizzes rapidly and the hydrogen produced may burn with an orange flame before the sodium disappears. Sodium plus water is sodium hydroxide plus hydrogen. 2NaS plus 2H2OL is 2NaOH AQ plus H2Q. Strong alkalis. The hydroxides formed in all of these reactions dissolve in water to form alkaline solutions. These solutions turn universal indicator purple, showing they are strongly alkaline. Strong alkalis are corrosive, so care must be taken when they are used, for example by using goggles and gloves. Reactions of metals with steam. Reaction of magnesium with steam. It reacts vigorously with steam. After reaction, the products formed are MgS plus H2OL is MgOAQ plus H2OG, magnesium oxide MgO and hydrogen gas. Reaction of zinc with steam. It reacts quite slowly with steam. The products formed after reaction are ZnS plus H2OL is ZnOAQ plus H2G, zinc oxide ZnO and hydrogen gas. Reaction of iron with steam. Reacts slowly with steam and the products formed are 3FeS plus 4H2OL is Fe2O3 AQ plus 4H2G, iron oxide Fe2O3 and hydrogen gas. Reaction of metals with hot water. Magnesium reacts with hot water to form magnesium hydroxide and hydrogen. It starts floating due to the bubbles of hydrogen gas sticking to its surface. Mgs plus 2H2OL is MgOH2AQ plus H2. Products are magnesium hydroxide and hydrogen.
Reactivity series.
Properties of water. Pure water shows the following properties. Pure water is tasteless, it is transparent, it is colorless, it is odorless, it can exist as solid, liquid or a gas. It boils at 100 degrees centigrade at normal atmospheric pressure to form steam. It freezes at 0 degrees centigrade at normal atmospheric pressure to form solid ice. It is a good solvent. It has a density equal to 1 gram by centimeter cube. It does not conduct electricity. It is a poor conductor of heat. Water is a good solvent. Water does not dissolve everything in it, but it dissolves many substances in it. It is therefore called a universal solvent. Hardness of water. The water which lathers readily with soap is called soft water. Some examples of soft water are distilled water and tap water. The water which does not lather with soap is called hard water. Some examples of hard water are sea water, well water, etc. The hardness of water is due to the presence of certain dissolved salts of calcium and magnesium in water. Falling salts of calcium and magnesium when dissolved in water can cause hardness of water. These are calcium sulfate CaSO4, calcium bicarbonate CaHCO3 magnesium sulfate MgSO4, magnesium bicarbonate MgHCO3, calcium chloride CaCl2, magnesium chloride MgCl2. Differences between hard water and soft water. Hard water does not lather with soap. Hard water contains dissolved chlorides, sulfates or bicarbonates of calcium and magnesium in it. Examples: river water and sea water. Soft water lathers readily with soap. Soft water does not contain chlorides, sulfates or bicarbonates of calcium and magnesium in it. Example: distilled water is an example of soft water. Types of hardness. The hardness of water is of the following types: temporary hardness of water, permanent hardness of water. Temporary hardness. The hardness of water which is caused due to the presence of dissolved calcium and magnesium bicarbonates in it is called temporary hardness. Temporary hardness can be removed by simply boiling the hard water. Permanent hardness. Permanent hardness. The hardness of water which is caused due to the presence of dissolved calcium and magnesium chlorides and sulfates in it. Permanent hardness cannot be removed by boiling. Removal of hardness of water. The hardness of water can be removed by following methods. Removal of temporary hardness by boiling. Temporary hardness caused due to dissolved calcium bicarbonate and magnesium bicarbonate can be removed by boiling. It is all due to heating for some time. Soluble calcium bicarbonate and magnesium bicarbonate salts present in water decompose to form calcium carbonate and magnesium carbonate respectively. These remain insoluble in water and are then separated by filtration. Reactions. CaHCO3 calcium bicarbonate, heat boil CaCO3 calcium carbonate insoluble plus CO2 carbon dioxide plus H2O water. MgHCO3 magnesium bicarbonate, heat boil MgCO3 magnesium carbonate plus CO2 carbon dioxide plus H2O. Removal of temporary and permanent hardness by adding washing soda. Washing soda or sodium carbonate Na2CO3 can be used to remove both types of hardness, temporary and permanent hardness. After reaction of washing soda with calcium and magnesium salts present in hard water, insoluble carbonates of calcium and magnesium are formed which are removed by filtration. Calcium bicarbonate present in hard water reacts with washing soda to form calcium carbonate and sodium bicarbonate. Reaction CaHCO3 calcium bicarbonate plus Na2CO3 sodium carbonate, ACaCO3 calcium carbonate plus 2NaHCO3 sodium bicarbonate. Magnesium bicarbonate present in hard water reacts with washing soda and magnesium carbonate and sodium carbonate are formed. Reaction MgHCO3 magnesium bicarbonate plus Na2CO3 sodium carbonate is MgCO3 magnesium carbonate plus 2NaHCO3 sodium bicarbonate. Removal of permanent hardness caused due to calcium and magnesium chlorides and sulfate. Calcium sulfate present in hard water reacts with washing soda and calcium carbonate and sodium sulfate are formed. CaSO4 calcium sulfate plus Na2CO3 sodium carbonate is CaCO3 calcium carbonate plus Na2SO4 sodium sulfate. Magnesium sulfate present in hard water reacts with washing soda to form magnesium carbonate and sodium sulfate. Reaction MgSO4 magnesium sulfate plus Na2CO3 sodium carbonate is MgCO3 magnesium carbonate plus Na2SO4 sodium sulfate. Calcium chloride present in hard water reacts with washing soda to form calcium carbonate and sodium chloride. Reaction CaCl2 calcium chloride plus Na2CO3 sodium carbonate is CaCO3 calcium carbonate plus 2NaCl sodium chloride. Magnesium chloride present in hard water reacts with sodium carbonate to form magnesium carbonate and sodium chloride. Reaction MgCl2 magnesium chloride plus Na2CO3 sodium carbonate is MgCO3 magnesium carbonate plus 2NaCl sodium chloride. Difference between temporary and permanent hardness. Temporary hardness. Temporary hardness is caused due to the presence of dissolved carbonates of calcium and magnesium in water such as calcium bicarbonate CaHCO3 and magnesium bicarbonate MgHCO3. This type of hardness can be removed both by boiling and by adding washing soda. Permanent hardness. Permanent hardness is caused due to the presence of dissolved chlorides and sulfates of calcium and magnesium in water, such as calcium chloride CaCl2, magnesium chloride MgCl2, calcium sulfate CaSO4 and magnesium sulfate MgSO4. This type of hardness cannot be removed by boiling but can be removed by adding washing soda Na2CO3. Advantages of hard water. The minerals like calcium and magnesium present in hard water are good for the formation of healthy teeth and bones. Dissolved calcium and magnesium salts impart a pleasant taste of water. Add to your knowledge. Forms of water. Water on the earth is found in all the three states, solid, liquid and gas. In the liquid form, water is present in oceans, rivers, seas, lakes, ponds, etc. In the solid form, water is found as ice and snow on high mountains, glaciers and at the poles. In the gaseous form, water is present as water vapor in the air. Potable water. The water we needed to drink every day to remain healthy should be clean. The water that is fit for drinking is called potable water. Drinking water is not absolutely pure. It must contain certain minerals and salts essential for our body. Fast track chapter at a glance. Water is present on the earth in all the three physical states, solid, liquid and gas. The various sources of water on the earth are rainwater, surface water, snow, river water, sea water and groundwater. Pure water is tasteless, it is transparent, it is colorless, it is odorless, it can exist as solid, liquid or a gas. A solution is a homogeneous mixture of two or more chemically unreactive substances. A solution that has dissolved the maximum amount of solute at a particular temperature is called a saturated solution. The relative amount of solute and solvent present in the solution is known as the concentration of the solution. A colloid is a heterogeneous system in which one substance is dispersed as very fine particles having size in the range of 1 nm to 100 nm in a continuous medium of another substance. A colloid in which dispersed phase is solid and dispersion medium is liquid is called colloidal solution or sol. The water which lathers readily with soap is called soft water. The water which does not lather with soap is called hard water. The hardness of water is due to the presence of certain dissolved salts. The hardness of water which is caused due to the presence of dissolved calcium and magnesium bicarbonates in it is called temporary hardness. The hardness of water which is caused due to the presence of dissolved calcium and magnesium chlorides and sulfate in it is called permanent hardness. The hardness of water can be removed by boiling by adding washing soda. The water that is fit for drinking is called potable water.